So today we're going over the notes for 1.1 and 1.2 in Algebra 2. We're going to start off with some definitions of numbers, or of different types of numbers. This is kind of like an umbrella effect where real numbers is going to be the overarching type of number, and then all the others fall below it. So all our real numbers are all numbers. Okay, so some examples of real numbers are 5, -13, 1/8, 0.75, and there's lots of numbers, right? Next, we move on to the rational numbers. Okay, so here's our real numbers. It's the big box. And next, for rational, it's that next box inside there. Okay. Rational numbers can be written as fractions or decimals that end or repeat. And that last part is really important. Okay, those decimals have to end or repeat. They can't keep going on. So, some examples of those rational numbers are 7/8, 0.33 repeating. We could do the square root of 16/9, and those are just a few examples. So rational numbers is going to be in this box here. And then inside rational numbers is integers, so let's go ahead and jump down to that. Integers are negative and positive. Numbers, and there's no fractions. So these numbers are -5, -4, -3, -2, -1, 0, 1, 2, 3, and so forth. Okay, so they're all those numbers, positive and negative, that are whole. So back up here in our box diagram, integer would be the next one. And then we have one more small box in there, and that's going to be our whole numbers. Whole numbers are positive only, so positive numbers. None of the negatives this time, and no fractions. So these are the basic numbers you learn when you're in kindergarten or preschool, or the 1, 2, 3, 4, and so forth. Okay. Last, we're going to go over irrational. They have their own special box in here under real. Okay. And irrational numbers are decimals that don't end or repeat. And they can't be written as fractions. So some examples of those are pi. Pi is one of those never-ending decimals. The square root of 2/5. 0.303003003000. Notice how it's not a repeating pattern. It keeps changing. That's also an irrational number. Okay, so now that we've gone over some of the definitions, we're going to go on to some examples. Our first example is to graph the real numbers, the square root of 5 and 7/2 on a number line. So let's go ahead and start by drawing our number line. We know that square root of 5 and 7/2 are both positive, so we could start by just drawing the positive numbers on the number line. Now it's important to realize we have to go far enough that our number line will include both of these. Okay. So 7/2 we know is 3.5, because 2 goes into 7 3 times, and then you have 1 left over. Square root of 5, we don't know an exact value, but we can guess without using a calculator. The square root of 5 is close to the square root of 4. So we know it's going to be a little more than 2. Okay, so let's go at least as far as 4 on our number line, because we have 3.5. Now let's plot these. The square root of 5, we determine it's a little more than 2. So we can put it about right here. I'm going to go ahead and label that for us. And then 7/2 is 3.5, so between 3 and 4. Now, as you can see from plotting them on a number line, 7/2 is the greater number. And that's it for that example. All right, in example 2, we have some word problems to go over. So in part A, it says you work 8 hours and earn $60. What is your earning rate? So your earning rate is how much you're making per hour. Dollars per hour. Then important information is you worked 8 hours and your total earnings were $60. Okay. So to figure this out, if it's dollars per hour, how much money you make needs to go on top of a fraction, and the number of hours you work goes on the bottom. So we have 60 over 8. You can reduce this down. If you divide top and bottom by 4, you get 15/2, and that's a little easier to figure out without a calculator. 15 divided by 2 is 7.50. So you make $7.50 per hour. And that's it. For part B, it says you buy 18 gallons of gasoline at $2.65 per gallon. What is your total cost? Okay, so we're trying to figure out total cost, how much you paid for all of the gas. We bought 18 gallons, and each gallon is $2.65. So to figure out how much we paid for total, we need to take the number of gallons times the cost per gallon. So 18 times $2.65. And our total cost would be $47.70. All right, part C, you drive 90 kilometers per hour. What is your speed in meters per second? So this one's a little more complicated. We're trying to convert our speed to meters per second. We start in kilometers per hour, so we're going to need some conversion rates here. So we know we're starting with 90 kilometers per hour. So we write that as our fraction. Kilometers on top, per is the fraction sign, and then hour. Now I know there's 1,000 meters in 1 kilometer. So I want to keep meters. That's what we're trying to get. I want to get rid of kilometers. If I'm trying to get rid of kilometers, I put it on the opposite side of where it's at right now. Since kilometers is on top, I'm going to put kilometers on the bottom for the conversion. So 1 kilometer is 1,000 meters. So we got rid of the kilometers that way. Next, we need to change hours to seconds. So first, let's change hours to minutes, because that's easier. So if hours is on the bottom, initially, we need to put it on top to get rid of it. 1 hour, and that's 60 minutes. Then we can do one more conversion to change minutes to seconds. So again, minutes is on the bottom here. I'm going to put it on the top to get rid of it. 1 minute is 60 seconds. Now, notice kilometers units is going to cancel out. Hours units cancel out, because whenever you have one on top and on bottom, they're going to cancel. And minutes cancels out. So we are left with meters on top, seconds on the bottom. And that's what we want, because it says meters per second. Then we're going to multiply straight across the top. So we're going to have 90 times 1,000. You don't have to multiply by those extra ones. And on the bottom, we have 60 times 60. You're going to figure out that math, and your ultimate answer should be 25 meters per second. Okay, we're going to do a little more conversion on example 3. So for the first conversion, we're doing 23 feet to yards. So I'm starting with 23 feet. I'm going to multiply by a conversion. So here, if we're trying to get rid of feet, feet will be on the bottom. Yards is what we're trying to get, and that will be on top. So we have to figure out, for every 1 yard, how many feet are there? There's 3 feet. Then we can multiply straight across. Notice the feet will cancel out. If it helps, you can put the 23 over 1 to multiply straight across. Ultimately, you should get 23 divided by 3, which is 7 2/3 yards. So notice I did not change this to decimals. We're going to try and avoid decimals as much as we can. If it doesn't start in decimals, we don't want to end in decimals. I was able to figure out that 3 goes into 23 7 times for that whole number. Well, 7 times 3 is 21. So if I take 21 away from the 23, I have 2 left. And so that's where the 2/3 comes from. For part B, we're changing 6 days to seconds. This is going to be a little more of a complicated conversion. We're going to have to convert multiple times. So I start with 6 days. First, let's change days to hours. Then we can change hours to minutes and minutes to seconds. So I'm putting days on the bottom to get rid of it. And there's 24 hours in 1 day. Now to get rid of hours, 1 hour is 60 minutes. I'm going to encroach on this other box here. 1 minute is 60 seconds. Okay, so we can cancel out some units. Days cancels out, hours cancel out, minutes cancel out. So you're left with seconds here, which is what we want. You always want to make sure those cancel out properly. Now along the top, we're going to do 6 times 24 times 60 times 60. And the bottom is just a bunch of ones, so you don't have to include that. Your total is 518,400 seconds. And we're done. For part C, we're changing 12 ounces per cubic meter to gallons per liter. All right, so I'm starting with, actually, you know what? Let's go ahead and cross that one out. I'm not going to worry about that one this time. And here, identify the power, exponent, and base in 5 cubed. So if we have 5 to the 3rd power, the big number is the base. The little number is the exponent. And then the whole thing is actually the power. In example 5, we're going to evaluate these exponents. So there is a difference in answers between A and B. Notice part A does not have parentheses around the negative 13. Part B does. So when there's no parentheses, that means that squared only affects the 13. It does not affect the negative in front. So when there's no parentheses around a negative number like this, your answer will be negative. So your answer is negative 169. Here, the parentheses indicate that we are squaring negative 13. So it's negative 13 times negative 13, which in turn becomes a positive 116. In example 6, we're going to evaluate 3x squared plus 5x minus 12 when x equals negative 4. So the first step for this is we need to substitute for that x. We're going to make every x a negative 4. So we have 3 times negative 4 squared plus 5 times negative 4 minus 12. Using order of operations, I'm going to do this exponent first. Negative 4 squared is 16, so 3 times 16 plus 5 times negative 4 minus 12. Now I can multiply. 3 times 16 is 48. 5 times a negative 4 is a negative 20, so that becomes minus 20 minus 12. 48 minus 20 is 28, and 28 minus 12 is 16. So notice when I show my work, this is going to be important when you do your homework, I show it going down the page. This is what you want to do as well. Show work going down the page. I know this was in your syllabus, but I like to reiterate it when we go over notes and lead by example. Okay, next example. In example 7, we're going to identify the variable terms, constant terms, and coefficients in the expression. Okay, so variable terms, that means they have a letter in them. So for our variable terms, we have 3x squared and 5x. You do want to pay attention to the signs in front when you determine these answers. So that becomes important with constant terms. Because that's a minus 7, which means our answer for constant terms is a negative 7. Last, we're going to identify coefficients for this example. Coefficients are the numbers in front of a variable. So we have 2 of them here. In front of 3x squared is the 3, that's a coefficient, and then 5 is also a coefficient. Okay, example 8, we're going to simplify these expressions. So simplifying means we're going to combine like terms. I'm going to start with the largest exponent. So here I have cubed, 8x cubed minus x cubed. So 8 minus 1 is 7, so we have 7x cubed. Then I'm going to do the squareds. There's only one of those, plus 2x squared. Then we have the plus 5x minus 11. And notice I color-coded mine to kind of help you follow along. I know some people also like to use shapes, so you'd use triangles for the cubed, a circle for the squared, a rectangle for the 5x, and then a square for the negative 11. It's totally up to you, whatever helps you get through it. For this next one, before we can combine like terms, we do have to distribute. So I'm going to start by distributing the x to get 6x minus 6. For this next part, we are distributing a negative 2. Okay, we have to bring that minus sign with the 2. So that becomes a negative 10x minus 16. So now I have 6x minus 10x, so that's a negative 4x. And negative 6 minus 16, which is a negative 22. And we're done. Order of operations, I'm sure you guys have heard this before. It's the order in which we simplify problems. So usually people use PEMDAS. Which is fine. There's just some important things to remember here. First, P stands for parentheses. E is exponents. M is multiplication. D is division. A is addition. And S is subtraction. Now there's some important things to remember. Like I said, the multiplication and division you do from left to right. So the same order we write in. So looking at a problem, you look from left to right. If division comes first, then that's what you do first. If multiplication comes first, that's what you do first. The same rule goes for addition and subtraction. They are also left to right. It is important to follow this because if you don't, you will not end up with the right answer. So we have one problem left to go over here in the notes, and this example deals with applying order of operations. For this first problem, notice there's two sets of parentheses. We're going to start with the innermost set. So I have 5 plus 3 times 2 plus 5 times 8 minus 1 is 7. Now I'm going to work on the inside of this next set of parentheses. 5 plus 3 times 2 plus 5 times 7 is 35. So notice I multiplied before I added, because order of operation says multiply first. Now I can add inside there. 5 plus 3 times 2 plus 35 is 37. Now, a mistake I see often is students will do the 5 plus 3 first. That's addition, and addition comes after multiplication. So we need to multiply 3 times 37 first, which is 111. Then we can add the 5 to get 116. And we're done. Now for part B, we have a fraction. We can do one step on top and one step on bottom at the same time. That's fine. So on top, we have addition and subtraction. Notice they are going from left to right. So if we're going from left to right, we don't do addition first, we do subtraction first. 33 minus 2 is 31 plus 1. On the bottom, 2 times 7 is 14. Now we go back to the top and start over. 31 plus 1 is 32. Still over the 14. Then we want to reduce this. I know 32 and 14 are both divisible by 2 to get 16 over 7. And I will leave my final answer as that improper fraction. And that leads us to the end of these notes for today. If you have any questions, be sure to contact your teacher.